Hey, what's up, guys? Chung here again. So this time, let's take a look at this lead code problem here, number 904, fruit into baskets. So you're given like array of trees, and the numbers on this position tells you the type of the fruit. And you can start at any tree of your choice at any positions. You can only repeat the following steps. So once you are at this position, you can only do two things. You either pick one, add one to the fruit, and if you can't, you stop, right? Basically, and then you move to the next tree, right to the current tree. If there's no tree to the right, stop. So, so basically what it's saying is that you have two baskets here, right? So basically you have two baskets. You have two baskets, all right, and you can start at any positions. When you uh, every time when you see a tree, you have to. I mean, if the basket is empty, you have to put this fruit into this basket, and if this one is not, let's say if there's one in this basket and two in this basket, when you see another one here, you have to basically you increase this one, put another one here, all right, and then and if you see if there's another three here, right? If you see it's a three, then you don't have any places, you don't have extra bucket to pick this number three, right? So you have to basically stop, and it asks you what are the maximum type of fruit you can pick with these two baskets. Okay, so the idea here is that we'll use a sliding window idea here, and amount of fruit you can collect. Hold on, let's see. Okay, and it asks you the total amount of fruit you can collect with this procedure. Then what's the total amount? Total amount is the actually how many trees you can you can traverse basically, right? Basically, step, how many steps you can make while satisfying these conditions, right? So that's why we're gonna need use a sliding window here. And the idea here is that with a sliding window, we're gonna use a counter. We're gonna use a counter to count uh, what's our current, how many type of fruit we have been collecting so far, right? If the current counter is greater than 2, then we know, okay, we cannot we cannot satisfy the condition. Then we just try to shrink the left counter until until the counter uh, went goes back to 2. Then we know, okay, we have another valid process. Then we update the distance between the left and the right pointer. And then we just traverse the entire tree. And then that's how we can start at any positions, right? I mean, we can try we can also try like positions from the starting point, and we try everything until we the brute force way is we always try from here. We try from here, and then we try to pick as many fruit as possible, right? And then we stop until the counter is bigger than 3. But then there will be then that will be like a n square time complexity, right? Because this could be 1 2 1 2 1 2 1 2, right? Then every time when we add the new positions, basically will basically traverse all the way until the end, right? Which will makes the time complexity to n square. That's not very efficient. With the sliding window here, right? Since we're always traversing the nodes like once and then basically twice, right? The left pointer and the right pointer. The worst case is we traverse this the time complexity is gonna be 2n, right? That's why the the total time complexity for the sliding window is n is O n here. So okay, let's try to code these things. Uh, define the tree length, okay, and then we have a left and a right, okay. Left equal to 0, and then and counter uh, default integer and for right fruit enumerate tree, right? So uh, we do a counter fruit increase by 1, right? Basically we every time we see a new fruit, we increase counter, right? That's basically the counter. The length of the counter is equals to our basket, right? And if the length basically while length of the counter is greater than 2, right? And then we know okay we cannot pick anymore, and we'll try to shrink the left pointer, right? We shrink it by do a counter left, right? We decrease by 1, right? So because that's the left corner is the one we're gonna be shrink from. So basically in the end we're gonna do a left pointer move forward, right? And then if the counter dot left is equal to 0, right? Then that's when we need to remove it, right? That's if we have removed all the fruit we have picked for this type of sorry, for this type of fruit here, because we're saving the type of fruit in this counter, right? And then we can delete it, which means we're gonna free this, like make this one basket available again, right? Counter left, right? Then every time when this condition is satisfied, right? we do a maximum here, right? We do a answer equals to max answer dot right minus to left. Okay, and I think we need to do a plus one here. In the end, we simply return the answer. So I think this should just work. Yeah, let's try it. Cool. So pass basically just we need just a sliding window concept here since we're going to trying to reduce the all the reduce trying each of the positions here, right? That's why we use a sliding window here because if you do a start from the same thing start over same thing for each of the index here, you will be doing some duplicate processing here. But with sliding window here, we're guaranteeing that it's always moving forward, right? And we'll be stop basically we'll be stopping here. We stop if the counter is still 2, right? So if we have 1 2 1 2 1 2 1 2 1 2 like many 1 2 here, and then if we have a if we have a 3 at the beginning and 3 in the 3 in the beginning and 3 in the end, right? So while we're moving, we have 3 here when we have 1, right? Then if we have 2 here, right? So when we have 2 here, we see, okay, so the counter is greater than 2 now. So that's why we need to shrink the left side. And then the left side becomes to here, right? And then we keep moving this 2 until all the way, right? All the way to here, right? That's when we see a third counter, right? And then that's when we keep updating this result until we see a number 3 here, right? When we see a number 3 here, so we'll be trying to shrink the left side, right? Until we see until we there's only one less than 2 uh, counters here, right? And then we shrink the left side, right? Whatever in between here will not be recalculated because we're using the counter to check, right? To check the what if we are reaching the another valid state, okay? And then we just in the end we just update the answer here. And okay, cool. I think this is that's everything I want to talk about for this problem. It's a it's another interesting sliding window problem here, and there's some other similar problems in LeetCode. You guys wanna if you guys are interested, you should check that out. Okay, I think I'll be doing a little bit more sliding window problems in the future, and stay tuned, guys. And thank you so much for watching the videos. See you guys soon. Bye bye.